All right, today's Trek into DIY Tech, we're going to look at some footage, some older footage, some ancient technology. By now, you know, technology moves at a blazing pace. So this is we're going to contrast an older device with a newer device, and yeah, see what those things look like these days. I hope the audio's okay because they've been driving sheet piles for weeks now. They're repairing some of the damage from Hurricane Ian, as everybody is around here. We're still recovering from that, but the road, part of the road where I am, collapsed, and so they're driving sheet piles to get that repaired. So I hope that's not too loud and we can actually record. That's part of the reason I haven't recorded a video in weeks as well. So anyway, here we go. Let's take a look. Okay, so this is this is, you're going to see a similar device in the video that you're about to see, and this is a small CPU that you would use when you're designing industrial systems. And the way you had to program this was you'd use this little keypad and you'd go through the menus and select, they called it ladder programming, right? So it's ladder programming. An event happens, or you have an input that comes in, and then you connect that to an action on an output. And so you would go through, scroll through the menus on this little keypad. And when you found the function that you needed, you selected the function, and then you selected the conditions for that function, and then what that function triggered on the output. So what condition to set the output to. And you had timers and functions like that. So input came in, timer ran through a certain amount of time, and then it triggered the output, things like that. So without getting into too much detail on that, it was up until they came up with some software. So years later, they came up with some software that you can have on your laptop, and you can kind of do it visually, and then that converted it into ladder programming, and it put it on this device for you to use. So a few years ago, I saw that Arduino, and you guys know I'm a big fan of Arduino, they came up with a PLC as well, and this one, I'm sure it's a lot easier to program. I haven't dug too deep into this guy, but I'm sure it's tons easier to program, being that it's built on the Arduino architecture. But here we are. You know, it's come things have come a long way. So wow, this is very interesting. I'll take a look at this later, but the idea is that even though you see it has the same shape still, there's no screen there. I'm sure they have a version with a screen on there. So this is not an advertisement for either one of these companies. It's just I've used this one, and I'm a big fan of Arduino. So that's why I'm showing you those two. But here, let's go on to the video that I actually want to show you, now that I've explained, you know, giving you a little bit of context as to why I'm showing you the video. You know, I just recently found the video again, cleaning up some files again, as I do, and thought you guys might be interested. Okay, I hope you don't mind the mess, but here's the overview of the mini touch tester here. So we got the 24 volt power supply. We have a Siemens logo PLC. Here we got the manifold with the pneumatic adjustment there. So, pneumatic valves to cut off each finger individually. Custom power supply board just to provide inputs to the PLC. Stop and go button. Well, obviously it's programmable through the PLC. We get the air coming in We got the lines going there, and they come into these two Festo pneumatic cylinders, and on the tips we have the finger simulators, which is actually just a cap and a resistor. It's a 1.5K cap and a 100 picofarad capacitor. It's going right to a piece of foil tape that wraps around to the front of this little square piece of plywood, and there's a conductive foam piece to provide the tip of the finger there. And so let's crank this up so you can see how it goes. I'm going to start it up here, and it's also got a counter and everything, so you can count how many touches you've got. But there it goes. And as you can see, the fingers are actually registering. This is a capacitive touch panel. So there you go. And the position and everything is adjustable. I just release this, and we can slide those back and forth. And this is just a clamp, as you can see. And those brackets allow the pneumatic fingers to slide back and forth on there. There you go. All right, that's pretty cool, right? So you might be thinking, why do you need such an elaborate setup? Or why did you need such? Because this was many years ago. This is the thing. In a lot of the testing, sometimes we had to put it in a chamber, an environmental chamber, and run the test inside the chamber and have, the touches going. Obviously, you can't have somebody sit there also and touch this thing until it fails in the same spot repeatedly over and over again. So you obviously you need a robot to do that. And so the thing is, though, that in some instances, and I'm going to show you the predecessor to this thing. Yeah, here. As you can see there, it's got a solenoid, a spring, and everything like that. So these were electrical, and so therefore, when you did the emissions testing, which is testing to see if this thing is radiating at frequencies that would, stop your pacemaker and interfere with other equipment, which is obviously bad. When you're doing that type of testing, you can't have other electrical signals around other than the equipment that you're doing the testing on, right? Makes sense. So, so I came up with this pneumatic system to do the touches. But anyway, that was the whole deal. But the PLC came in really, really handy for this because it's timing based, right? So if you needed to have a touch, you needed to touch the screen, hold it there for a certain amount of time, and then lift up, and then do that with two fingers, because this was a believe it or not, before a certain time, you didn't have screens that you could do multi-touch on, right? Where you can have multiple touches at the same time and do gestures and things like that. There was a time when you could only touch the screen in one spot at a time, and if you tried to do two touches, it would average that out and go in the middle. Especially with resistive touch screens, which that finger solenoid powered finger is what was used for that one. But anyway, that's it. I know this was about PLCs, and then we wound up on this whole pneumatic touch tester thing, but it was something that used that PLC, so it's a good example. Anyway, as always, I appreciate the time you spend with me, and we'll see you in the next video.